Welcome to this explainer. If you're looking to demystify the AC safety architecture of off-grid solar inverters, well, you're exactly in the right place. Today, we're getting our hands dirty. We're going to break down exactly how to wire up a protective earth and, yeah, that notoriously misunderstood NPE bond, just to make absolutely sure your isolated power systems are entirely safe. Here's the roadmap for the step-by-step journey we're taking today to build a fully autonomous, safe electrical panel from the ground up. We'll cover the off-grid safety island, the earth connection, that critical NPE bond, surviving an electrical fault, the strict safety hierarchy, and finally, the 5 essential components. Let's get into it. Part 1, the off-grid safety island. Look, we gotta bust a common myth right out of the gate here. Just generating 230 volts of AC power? Yeah, that isn't enough. When an inverter operates totally independently from the utility grid, it basically creates its own tiny electrical network. It's an island. Now, producing voltage obviously requires your line and neutral terminals, typically your orange and blue wires. But to make that island actually safe, you absolutely have to utilize that third terminal, the green protective earth, to build a custom protective architecture. Seriously, before you even think about connecting a single appliance to your system, you have to hit 3 major safety milestones. We're talking proper earthing, setting up an RCD, and making that NPE connection. Without these, your system literally cannot clear dangerous electrical faults safely. So let's build each one out. Moving on to part 2, foundation, the earth connection. All right, our physical build starts right now. You absolutely cannot just rely on the inverter itself for grounding. You need a rock-solid physical connection to the actual earth. We're talking about a copper earth rod driven deep into the soil. From there, a green grounding conductor needs to run straight up and directly into the main protective earth, or PE bar, inside your distribution box. That bar, that becomes your absolute safety hub. Once you've got that hub established, we have to strictly follow what I call the absolute rule. Every single piece of exposed conductive material, the inverter chassis, the metal enclosures, your water heater, the whole shebang, has to route directly back to this one central PE system. If it's metal and it could potentially carry a fault, it gets wired to that PE bar. No exceptions. Which brings us to section 3, the critical NP bond. This is arguably the most crucial and, honestly, the most misunderstood step in the whole process. By physically linking the neutral conductor directly to the protective earth bar, we are establishing a vital reference point. Without this specific link, your circuit breakers and RCDs are essentially flying blind. They completely lack a return path to the inverter during a fault, which means they literally won't even know a fault is happening. It requires absolute precision. You have to physically connect the neutral and the protective earth. But here is the kicker, and this is a critical action. You can only do this exactly once. Actually, let me repeat that for emphasis. Only once. If you try to make multiple NPE connections inside the same isolated system, you are going to cause massive protection failures. The golden rule here is one island, one bond. Okay, part 4, surviving an electrical fault. So what does this all mean in the real world? Let's simulate a worst-case scenario. Imagine we have an earthed system, but we forgot the NPE bond. Now, say a line wire accidentally touches the metal casing of a water heater. Because there's no neutral return path to complete the circuit, very little fault current flows. And guess what? The breaker completely fails to trip. That water heater enclosure just sits there, dangerously energized, and remains entirely lethal to anyone who touches it. It's a terrifying thought, right? Now compare that to a properly bonded system. When that same fault occurs, the current flows into the enclosure, but this time it travels rapidly down that solid green PE wire, crosses that crucial NPE bond we just built, and safely completes the circuit right back to the inverter. Boom. A massive surge of current flows, and it instantly trips the switch, cutting the power and removing the danger in mere milliseconds. That bond is literally a lifesaver. Let's jump to section 5, the strict safety hierarchy. With the foundational grounding and bonding complete, it's time to organize the distribution board. Think of it like a hierarchy. Power flows down from the inverter, goes through the residual current device, or RCD, then down to the circuit breakers, and finally out to your electrical loads. And during this entire flow, that PE bar branches off to the earth electrode entirely independently, creating a very distinct safe separation. Now, this brings us to the post-RCD rule, and I really cannot overstate how important this is. After the power passes through the RCD, the neutral and PE lines must never connect again. If you cross them, you're creating those illegal multiple bonds we talked about. This allows normal return current to leak straight into the earth, which completely bypasses the RCD's delicate leak sensor. The result? Well, best case, your system suffers from constant frustrating nuisance tripping. Worst case, it totally fails to protect you when a real dangerous leak occurs.
So, if you're ever out there troubleshooting an off-grid system that just isn't behaving right, you need to understand what the most common fatal mistakes look like. On one hand, you might have the open circuit of a missing bond. On the other hand, you could be dealing with a tangled, chaotic mess of multiple bonds. What you really want to see is the clean, single parallel connection of a correctly executed setup.
It's super helpful to keep a mental diagnostic checklist handy. You can actually match your symptoms directly to wiring errors. For example, if your system seems properly earthed, but the protection fails during testing, you've probably got a missing bond. But if your RCD is constantly tripping for absolutely no apparent reason, you're going to want to hunt down those multiple bonds and get rid of them fast.
Finally, Section 6, the 5 essential components. All right, let's pull all these pieces together into one master blueprint. Think about the pathway. We start at the foundation with the physical ground rod. That earth connection travels up to our main PE hub. From there, it routes through that one single, absolutely crucial NPE reference bond. And only after that bond is made does the power route safely through the RCDs and the circuit breakers. When you nail all 5 of these components, that is exactly what a perfectly protected network looks like.
That brings us to the end of our build for this explainer. But before you go out there and flip the switch on your own autonomous setup, I want you to take a long, hard look at your distribution board. Ask yourself, is your off-grid system truly an island of safety, or is it just an accident waiting to happen? Take the time, trace out your NPE bond, and absolutely guarantee your system is fully protected. Thanks for tuning in, and please, stay safe out there.